thought I'd try something a little different here. I want to talk to you about isosceles triangle a little bit. We've already talked about isosceles triangles, generally before. And we know that an isosceles triangle is a triangle with at least two congruent sides. If it's got three sides, it's referred to be an equilateral, but it's also isosceles. Now, there's parts of the isosceles triangles I wanted to talk to you about. We have the legs of an isosceles triangle, and we have the base of an isosceles triangle. I'll let out a little bit further. Okay, the legs are the congruent sides of the triangle. The base would be the non-congruent side. Now, that doesn't mean it's always on the bottom, but it means it's the side that's not the same like that's the other. Now, in an equilateral triangle, all three sides could be considered the base. All three sides could be considered legs. Legs always come in pairs. So there's two congruent sides, so there's two legs. Okay, so now let's talk about the other side. We have a vertex angle, and we've got base angles. A vertex angle is the angle formed by the two legs, and the base angles, there's two of them, they're the angles formed by the base and one of the legs. There's two of them. So let's see what this actually looks like. So here we have the nice figure drawn out nicely for you. We have an isosceles triangle. Notice our two congruent sides. Magic pen, thank you. Our two congruent sides right there. Because those are the congruent sides, those two sides are the legs. And when those legs come together, that creates our vertex angle. At the very top of this is our vertex angle. Now down at the bottom is our non-congruent side. Remember, we called that the base. And since there's two angles formed off of that base, those are our base angles. So in our case here, angle A is the vertex angle. Angle B and C are the base angles. And it's because of the terminology there. So you need to know that terminology. Because what happens is we get some theorems here. And our first theorem is referred to in our book as the isosceles triangle theorem. I call it the side to angle isosceles triangle theorem because it works out that way. And it tells us that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So in this triangle that we have here, I've got side AB and I got side BC are congruent, which means angle A and angle C have to be the same measure as well. Now, this is a theorem we'll prove later on after we do some other things. I refer to it as the side to angle theorem or the side to angle isosceles triangle theorem because we start with the sides and we go to the angles. So that's the side to angle. Now, let's see, how is that going to play out in a problem that we're going to have to work in class? We're going to get a problem like this. Here we have this huge figure, and all we're told is that LT and LR are congruent. So LT and LR are congruent. So now the question is, which angles are congruent? Well, if these are the two sides that are congruent, the angles opposite that is the angle T here and the angle R here. But unfortunately, we cannot answer that as just angle T and angle R. So we would have to say angle LTS would have to be congruent to angle LRS. So we have to name the angles in three-dimensional pieces here. Okay, number 10 says LX, so that's this whole long side here, is congruent to LW. That's this whole long side here. Which two angles are congruent? Well, that would be this angle here at X and the angle at W, because those are the angles opposite that. We can ignore everything that's in the middle. Now, in this case, we can say angle X is congruent to angle W because there's only one angle at each of those spots. Now, let's look at the last one. If SL, that's this one right here, is congruent to QL, this one right here, which angles are congruent in the two congruent angles? Well, if those are the sides that are congruent, well, then the angles opposite that, so that would be this angle here where the S is and the angle where the Q is. But like the R and the T one, we have to name them with three-letter combinations. So I would say angle LSR is congruent to angle LQR. So those angles are congruent because the sides were congruent. Now, we do have a theorem that goes the opposite direction. I refer to it as the angle to side isosceles triangle theorem. Your book doesn't even give it a name, they just give it a number. Otherwise, you can call it the isosceles triangle converse theorem because it's going the opposite direction. So if two angles of a triangle are congruent, then the sides opposite those angles have to be congruent. So it's the converse of the isosceles triangle theorem. So if my angle D is congruent to my angle F, well, that means I have to have congruent sides that are congruent. So that's the way it works. Before we knew that we had sides that were congruent, gave us congruent angles. Now we got angles that are congruent, we're going to get congruent sides. So how does that play out in practice problems? Same figure. Now this time they told us that LXY is congruent to LYX. So go ahead and trace that out. LXY, LYX. So there we have it. We can see that we've got two sides, this side and this side being congruent. So LX must be congruent to LY, would be our problem. Now 13 says angle LSR, so that's this angle right here, is congruent to angle LRS, that's this one right here. So since this angle and this angle are congruent, it must mean that side LS is congruent to side LR. Now, did you notice something there? We have a little pattern. Keep an eye out for it. Okay, one more angle. If angle LYW is congruent to triangle or angle LWY, that one right there. Which two sides are congruent? So those are the two angles. So if I look at the triangle as a whole, okay, look at the triangle as a whole, and I have the two sides here that are congruent. The two angles that have to be congruent are the ones that aren't connected by that. So LY has to be congruent to LW. LY, LW. LS, LR. LY, LX. They kind of tell you which sides are going to be congruent there. Kind of a shortcut there. Okay, there are some corollaries to this, and it refers to the equilateral triangle. Corollary 4.3 is what our book calls it. A lot of people just call it, I don't know. So it's a triangle is equilateral if and only if it's equal angle. So if all three sides are congruent, then all three angles have to be congruent. Well, that kind of goes back to that theorem. And likewise, it's the equilateral triangle theorem. And that equilateral triangle theorem just says all three angles of a triangle, an equilateral triangle, have to be 60 degrees. Okay, so now we're looking at this problem here. So here I have this figure, and in this figure we are told that KLN and triangle LMN are isosceles, and notice they do have the marks on the figure to show that this side and this side are congruent, that this side and this side are congruent. And they tell us that the angle right here, this angle right here, is 130. So like the problems that we were doing for today with that, we want to use this information to figure out what other sides can we automatically identify as being congruent. So before I go in and I start answering their questions as far as which angles are congruent, I'm going to focus on this itself and go from there. I know this is a 130 degree angle right there. I know this is a 25 degree angle. Well, if that's 130 and this is 25, what do I need to finish it off? It's a 25 degree angle. Now, we're told in triangle LKN, right here, this big one in the middle, need to get my magic pin back, LKN, this triangle right here, we're told that it's isosceles. And this angle right here, the vertex angle, is 18. So if I take 180 and I subtract 18, I get 162. Now if I divide that by 2, I get 81. So each of these angles here are 81 degree angles. So now let's look at the small one. We're told that this angle down is small one. Let's look at this triangle here, the LMN. We're also told that it is isosceles, and we've got a 20 degree angle right down here at the bottom, which means I have a 20-degree angle right here at the top, and 20 and 20 is 40, and 180 is minus 40 gives us a 140-degree angle. So now we've gone through and we found every angle in this figure. So now we could actually go back and say, okay, what is the measure of angle LNM? Start at L, go to N, go to M. It's a 20-degree angle. What is the measure of LKN? That's this one right here. Ooh, that worked out really well. LKN is 81 degrees. And it says, what's the measure of angle M? This angle right here. That's 140 degrees. What's the measure of angle J? It's 100 and... Whoops, you made a mistake. Scratch that. That is 81. This angle here was 130. I pointed you in the wrong direction. So that's 130. Well, if that's 81, this is a 49-degree angle. That's a 25-degree angle. So I would take 180 minus 49 minus 25 to get my angle J. Sorry, I read that problem incorrectly. Good thing we can have a chance to fix it. So 180 minus 49 is 131, so this is a 106-degree angle. So that's a 106-degree angle. So it goes back to the fact that the three angles in a triangle add up to 180, and if it's an isosceles triangle, the two base angles are going to be congruent. Okay, that is what you're going to be working on the assignment.